Okay, I want to take a look at one of my favorite types of problems, which are clock problems. So clock problems are just an interesting mix of problems that require me to look at the angles created by the hands of an analog clock. So um, let's give an example really quick. So an easy example would be, what's the measure of the angle formed by the hands of the clock at I don't know, let's just go with something not too bad. Let's go with 4:30. Okay, so my goal is to find the angle that the hands of the clock make at that time. So I have to take into account several things. Let's just look at a clock in general. So if I have a general analog clock, what I have here is I have a circle and I have 12 different numbers on the face of my clock, like such. And so if I want to be able to figure out angles formed by the hands at a certain time, I need to know a little bit about just the degree measures that are involved in this circle in general. So one thing I should note is that one trip around a circle is in fact 360 degrees. Okay. Another important thing that I should note is how many degrees are in between each of my numbers. So for example, if it was exactly 1 o'clock, so my hour hand is right here and it's going towards the 12, and then my minute hand's going towards the 12, and then my hour hand's going towards the 1. What's the angle right there? Well, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different gaps in between numbers. And so each of those gaps, if I add them all up, should add up to be 360 degrees. So each gap is 30 degrees. Each of these is 30 degrees. Okay? So those are kind of the two big things I need to know to start these off, is that one trip around the circle is 360, and that in between each of the numbers is 30 degrees. So let us take a look then at the specific problem. So I just need to figure out where the hands of my clock are at 4:30, and then I can kind of count these gaps to figure out what the angle is that's formed by the hands. So here's another clock face. I want to talk about 4:30. So let's start with the easy one, the minute hand. So 4:30, the minute hand is going to be exactly at 30 minutes. So down here towards the 6. The interesting part, and this is the part that we have to be careful about, is where is the hour hand at? The hour hand is not on the 4. It's not on the 4. Because as we know, a clock, what it does is that at 4 o'clock exactly, the hour hand will be on the 4. But then my hour hand slowly moves from 4 to 5 over the course of that hour. So my hour hand is actually going to be somewhere in between the 4 and the 5. The question, of course, is just, well, how far in between the 4 and the 5? And the answer is, well, what fraction of an hour have I gone through? And in this case, I've gone through half of an hour. So what that means is that this gap right here, this is 30 degrees, which we just noted. And then from here to here is half of 30 degrees. I've gone halfway through the hour. So this is exactly 15 degrees. So what is the angle formed by the hands of an analog clock at 4:30? The answer would be 45 degrees total. So that's not too bad. Once we break it down and find all the parts, isn't too bad of a problem. Let's look at another one real quick. Let's look at another one. Same idea, but let's just look at a different time. So let's say I have, what time do I want to look at? How about we go with 9 and 15. All right, 9:15. So I'm going to draw my clock again. That wasn't as great, but oh well. I'm going to draw my different hours in here. Alright, so I'm going to start with my minute hand again. Where is my minute hand going to be? And so 15 minutes past the hour, my minute hand will be right at the 3. Now the question is, where is my hour hand going to be? So my hour hand is going to be well, a little bit past the 9, right? It's not going to be on the 9. It's going to be a little bit past the 9. How much? Well, it should be 15 minutes out of the 60, so 1/4 of the way from my 9 until my 10. So it should be 1/4 of the way. So I'm going to keep that in the back of my mind here for a second. Let's get rid of those. So let's start adding these up. So I'm going to look at this angle here that's formed, the one that's less than 180 degrees. So I have 30 here, 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 and then the question is, how much is this last part here? Well, let's just talk about this portion. So as we said, it's moved 1/4 of the way. Well, this entire distance is 30 degrees. 1/4 of that would be 30 divided by 4, which is 7.5 degrees. And so what's left over, this part is going to be 30 minus 7.5, so 22.5 degrees. So the angle formed here, this angle right here, is going to be 30 plus 30 plus 30 plus 30 plus 30 plus 22.5 will be the angle formed by the hands at 9:15, which would be 30, 60, 90, 120, 150, and that would be 172.5 degrees. Now I could have made it a little bit easier and just subtracted 7.5 by 180, but hey, this gets me there as well. Okay, so that's two basic examples of just finding the angles formed by two hands of the clock. Let's look at something that is a little bit more complex. So let me ask a slightly different question. So let's say starting at noon, when is the first time that the hands of my clock make a, let's go with 60-degree angle. So starting at noon, when is the first time the hands of my clock make a 60-degree angle? So let's go ahead and sketch this out. Take a look at it. So I have my clock again. Put my different hours on there. Okay, so first time it forms a 60-degree angle. So starting at noon, let's just start off by talking about where are my hands at noon. Well, right at noon, my hands are just stacked on top of each other, are both pointing at the 12. Okay, and so the naive answer to this question would be, well, I just need for my minute hand to move 60 degrees. And so I would just need it to end up being right here at the 2. So that would be 10 minutes past 12. That would be the first time that my hands form a 60-degree angle. Here's the issue with that. Here's the unfortunate thing. Whenever my minute hand is moving, my hour hand is moving as well. And so that means that my hour hand is actually a little bit past the 12. So I haven't quite made it to 60 degrees yet. So it's actually going to be a little bit past 10 minutes after the hour. So the question is, when exactly? Well, so here's how I'm going to think about things. Let's talk about the minute hand and how quickly it moves. So the minute hand, so how long does it take to get all the way around my circle here? It takes 60 minutes to make it all the way around. In other words, it moves 360 degrees, but it takes it 60 minutes to do it. So my minute hand is moving at a rate of, 6 degrees per minute. Okay? My hour hand, on the other hand, it only moves, in 1 hour, it only gets from here to here. It only moves 30 degrees. And now realizing I'm a little bit off the screen. Oh well. It only moves 30 degrees. So, in other words, I have to say this is degrees. It moves 30 degrees in 60 minutes. Or in other words, it moves 1/2 of a degree every minute. So how does that help us? Well, the way I like to think about it is that we're going to do this in terms of time. So we're going to set up an equation. So if I want to figure out how long it takes to get to 60 degrees, I'm going to use a variable and I'm going to call it t. So for every t minutes that passes, what is my minute hand doing? Well, my minute hand is trying to add on to the degree measure. So, after 5 minutes, my minute hand has moved here. It is attempted to add this much to the angle that I have formed. So for every minute that goes by, it is attempted to move the angle measure by 6 degrees. My hour hand, on the other hand, the second time I said that now, it's actually taking away from the angle that I'm creating, and so it's it's working against me. So it's actually taking away 1/2 a degree for every minute that goes by. So I can say then that the angle that's formed is going to be, well, whatever my minute hand has tried to add minus whatever my hour hand has taken away. So 6t minus 1/2 t. And what I want that to be equal to is, in this case, exactly 60 degrees. That's my goal. So this is just an equation I can solve. It tells me that 5 1/2 t will be equal to 60, and it's not going to come out to be anything nice. Let's go ahead. I'm going to bust out my calculator here. Turn this back on. So 60 divided by 5.5 is going to give me, t is about 10.909090, so 90 repeating. So that's how many minutes it's going to take. 10.90 minutes. 10.90 minutes from noon. So the question is, if I want to, can I convert this to a time that makes sense? Because generally speaking, we don't tell people what time is it. Oh, it's 12:10.9. That is not a time that we usually refer to. So what I'm going to take is this 0.9 repeating and multiply it by 60, and so I can give a time then. So this is going to be 12 o'clock, so 12:10, and how many seconds? Well, I'm going to take 0.9 repeating and multiply it by 60, and so it'll be 12:10 and 54.54 repeating seconds. That's how long it'll take for my hands to first reach a 60-degree angle after 12 o'clock. And so that makes sense, because as we said from the very beginning, is that this should be a little bit after 12:10, because my hour hand is kind of working against me here. So these are some basic clock problems that I think are interesting, but it's really just a way of applying the stuff about angles that we've learned.